GPU is better. I think GPU is faster and bigger cores.
Yeah.
More cache power, more cores for power processing. Yeah. Go to level 2. Okay, GPU architecture. Modern GPUs are organized in a hierarchy, streaming multiprocessors, group of cores that share control logic, CUDA cores, individual processing units for NVIDIA, because they're also AMD GPUs and other GPUs. Memory hierarchy, global shared constant and texture memory. Okay, so analyze your GPU specs. So let's see that. That's interesting. If I can do that, maybe I just copy this part and then I try to run the same and just add here, and we see it says okay. So here we query the index, name, memory, the total memory use, utilization, temperature. Okay, so this is the number of GPUs, because you could have multiple. I have 1060 with max Q design. I'll figure out maybe the naming where it comes from and so on, because there's GTX, RTX, TI, so on. I actually thought this was a TI, but see, 6 gigabytes, and it's been 550, so 9% is being used. Okay, and 80, that's pretty hot. Yes, I need to get my fan on. I was just playing video games earlier. Okay, so memory types, large but slow. So we got GDDR6. Okay, and I believe there's GDDR7 now. Yeah, but fast, small, shared with SM. Fastest, private to each thread. Big consumer, read only cache. Is the fastest. It's registers, because those are always closer to the actual cores. Okay, GPU programming basics. So, but one thing that I find really cool is that, for example, learning with games is a very sort of like interesting way, because look at this UIs. I mean, it's very like nice and so on. So, and if you have a progression, you can easily learn a lot without getting bored pretty fast, at least for me. So I like this, that LLMs can generate game, or in Claude's case, artifacts that you can use to learn something. And that's not the only thing, is that you could also have it as a companion, right? And so that's pretty cool. Because the alternative is like you could ask Claude or ChatGPT, explain to me about GPUs. They will output a lot of stuff, and you have to go through that, or either tell it to break it down and go step by step. And you know, it's sort of a lot of content being pushed to you, but this is more like chunked. Okay. Several APIs let you program GPUs. CUDA, NVIDIA's parallel computing platform, OpenCL, cross-platform parallel computing, OpenGL, graphics programming, okay, and compute cheaters, GPU computing and graphic pipelines. Okay, your mission, check GPU, check CUDA installation. Okay, I tried this already and I do have CUDA, and here I want to try this NVCC. So let's see if that's here. This is C. Yeah. And I think it was version. Yeah. NVIDIA CUDA compiler. And boom. Nice. And next we tried this. And it was here. Basically. And I think I tried print CUDA device. Okay, that's another one. So for now, I'll just remove this, add that, and I will change this also to use this. So this will basically tell you if you have CUDA is available. Wait, yeah, CUDA is available, and how many CUDA cores? I think. Oh, number of GPUs. Okay. I wonder. Okay, let's run this and see what we get here. This kind of annoys me because it's red and it tells me one device. So let's say print number of CUDA cores, for example. Is that possible? Okay. You gotta love LLMs, right? So let's run that and see what we get here. Anyway, CUDA available. One. This is the device. This is a memory. And number of CUDA cores. Now I know from a little bit of reading that there are also tensor cores and ray tracing cores. So let's see if I could do that as well. CUDA is available. Maybe I don't need that. I could there. I'm not sure, but we'll figure it out. Okay, so now create your first GPU program. Create a file called this, and we will put that. So I'll just do this manually and go here. Actually, I will just do it in the same file, because why not? Why not? Right, why not? So import numpy, import this. Okay, so I need numpy and I need something else. Pip here, yep. Pip install numpy and cup cupy. Okay, so let's try copy this code here and see, and probably format it. You know what? We will ask a friend here, add this code for me. It's usually annoying to do this, but I like doing it that way. And I think that worked. So I will do port that. Change it up a bit here. Okay, create nope. Create array. So, and add those arrays. Okay, I'll just run this and see what we have. Okay. I want to run the same operation using numpy, but I want numpy. I want to compare the time it takes for the two. Compare the time it takes, the time difference. Separate. Make two functions. One using CPU, one using GPU, I guess. Okay, CPU, GPU. And we will run CPU addition, GPU addition. Okay, so I will run this and we can see the difference. This completed in 0.0045 seconds. That's the CPU. This computed in 0.01 second. Okay. Not exactly what I expected, but because let's say what would that be? Micro, maybe nanoseconds. Show in nanoseconds instead. Okay, much better. So this shows that definitely this takes shorter time than this one. Almost half, right? Half the time. Therefore, similar to what we read before, that we can do more operations on the GPU than the CPU. I mean, this isn't the case for everything, but for example, in this addition, in this case, like an array that goes to vectors really, then GPU is better. And in that case, whenever we have vector addition, for example, we would use the GPU, and an area that's has a lot of vector operations is gaming and AI, machine learning. What is the advantage of CUDA over OpenCL? I think it's probably this. Okay, CUDA programming. Okay, CUDA execution model, collection of thread blocks, group of threads that can cooperate, individual execution, 32 thread executed together. Okay, write your first CUDA kernel. Okay, this looks like C++. And we can run it like this. Okay, so I will take this and I will go here and say create file for me to run this. Actually, yeah, let's do that first. To run this. And as that is running, I will go here and say, okay, what is CUDA? Yeah, that's actually a good question. CUDA programming refers to compute unified device architecture, parallel computing platform, and an API model created by NVIDIA. Is CUDA allows developers to write programs that offload compute-intensive portion of applications to the GPU. Yeah. Standard programming language to let you write kernels that execute parallel programming. So I could use Python also. NumPy, PyCUDA. Okay, for GPU arrays, TensorFlow chart, yeah. Okay. And I guess I can do other things, but I want to do something here, which is I want to run this, just hold the game for a bit and run this with that, right? So I'm gonna go and we see put, and I want to copy path, but I want to go, I don't think this will work because let's do this, okay? Let's do this and then we also go this, like this. See if that will work. Okay, so it worked. It's just we got this CL. Instead of doing this, I think it's very similar to what we already did, but because we did use CUDA here, turns out. So give me a cool example for me to learn a little bit about CUDA using Python. I have CUPY. Okay, what was that? I didn't see this. Oh, okay. Okay, that I do not have matplotlib, and we'll go pip install matplotlib and go here, and let's try this. So we can just go mandelbrot .py. I will just paste that here, and we can run it. Oh, that is super beautiful, right? That is super beautiful. Let's try. Let's try. make this into 4K. Can I do that with Copilot here? So I'll just start a new chat. Make this into 4K. I want a high resolution image. Okay. Is that only that? I thought there would be more here, but let's see. See, the detail is much better. That is actually cool. That is actually quite cool and beautiful. There's a lot of interesting math with Mandel broadsets. But yes, see NumPy, but what is it? Give me another one. So glad you're enjoying. Let's level up and use custom CUDA kernels in CUPy, where you write your own GPU kernel and run it directly. This is a GPU version. This is a GPU version of a classic at your CUDA kernel. Okay. Okay. But what is a kernel? No. Function that runs on GPU, not the CPU. A kernel is a function written to execute in parallel by many GPUs. Okay. Imagine you want to wash 1 person. Okay. Give me another visual example. Implementing a kernel. Okay. Okay. Let's see. Generate an image of an image for me to invert. Let's see if nice. So we will go and create another file here, invert.py, and then I will go here and say I will probably name it invert, and I will install OpenCV. This is quite interesting because now I can just do this and run it, and I don't think that will work because but OpenCV Python. Okay, so we'll close that. That will download, and you can look at what it's doing. So here it's just about the file. gets the size of the file, copy to GPU the image. Not sure what that does, but then define custom kernel for image inversion. This is the kernel invert, and this is basically a function, right? Parameters and so on, and multiplication and add, right? I've seen this before where it's like A, B plus C, because I think you can only do multiplication and add some other operations on the GPU, and then subtraction somewhere. Okay, some pointers here. Yeah, but let's say it's just a function that's doing some calculation and another calculation here, and then doing another calculation here. I think there's a name for this, but then let's continue. Then launch configuration hat. Don't know what that does. So read and then invert. It calls this invert kernel. Okay, calls this, yeah, calls a function. Copy back to CPU and plot it. Okay, so let's see. Ooh, that is Len actually. So I will take copy this and I will just put it here. Leave that copied. Okay, I'll just do that. Rename. We will keep it to Lena because that's her name now, Lena. And we'll go here and go Lena, and I think it's PNG. It's pretty sizable, so might take some time, but I will run it now and see what we get. Okay. Ooh, look at that. Took seconds and basically became grayscale. That's pretty cool. That is pretty cool. Okay, so I'll go back here and back to my game. I'll close this. And what is a wrap in CUDA? What is a wrap? What is a warp? Not a wrap, a warp. A warp. So I do not know what a warp is, but 32 threads executed together. Type of GPU, memory, probably not. Graphic, memory, location. I think it's A or B. I had to guess 32 threads executed together. Could be. I think it could be. But yeah. But let's see. What is warp in? What is warp? Come on. What is warp? Of 32 GPU threads that executed in lockstep, meaning they run at the same time. All threads in our warp follow the same code path. You launch 256 threads in your kernel code. Break it down into 8 warps. Right. Okay. Give me an example that just uses warp. Warp.py, and I'll just put that, and let's see. Works, but why 32? Because NVIDIA GPU architecture. How many CUDA cores did I again? Yeah. So what does it mean if I have 604, 640 CUDA cores? Okay, so now a GPU can also have tensor cores and ray tracing cores. Does GeForce 1060 Max Q design have those? In case you're wondering how I figured out this, I watched a nice video earlier that shows this. Okay, does GTX? No, so it does not support ray tracing, of course, and tensor cores. No. This is the architecture, Pascal GP. Of course. I think that's wrong, or maybe I got a different one, but yeah. Tensor cores introduced in Volta Tesla and Turing, Ampere architectures, designed for matrix and deep learning. RTX, so that's why it's called RTX. Okay. Why is it called GTX? Okay. What other models are there? I have heard of A100 and H100. So we have G4 series. These are consumer ones like computers, GTX, RTX, makes sense. We have the Quadro, I've seen that, RTX A series, CAD, video editing. Okay. Okay, so RTX, these are the beast. B100, okay. I've heard of that. And then this, those are not for gamers. These cards are not for gamers. Is it because of the cost? Gamers spend a lot of money on rigs, right? They use HBM memory. What is HBM memory? Server X, not desktop. And then we have the Jetson. I've seen those as well. Jetson Nano, Xavier Ori. Yeah, but there's one cool GPU I saw. It's not a PDF. Okay, I don't want to read. You read that. You read this, but before that, NVIDIA GPU for developers. Okay. These are data centers. Let's see. I can find an image of it. It looks something like this, but no. It wasn't DGX. I would like to see that also on, but there was a GPU. This one here. Project Digits. NVIDIA Project Digits. I think maybe it should. Something else? DGX Spark. Yeah. This a Grace Blackwell. What about DGX Spark? We can check here. So, CUDA cores, Blackwell generation, sensor cores, ray tracing cores, tensor performance, Type C, what? 128 GB you could run. Yeah. This is a Jetson boring. Okay, so there are definitely a lot of products, right? So there are different microarchitectures. Okay. Yeah, so that is pretty cool. And we've done with note 4. So, why GPUs? Matrix operations, neural networks are mostly linear algebra. And here you want to think of vector operations. Training can process many samples. Multi-dimensional array. Okay, so that's an interesting question. Vector operations are CUDA cores or tensor cores better? Okay. Intense operations, multi-dimensional array, and with large model, fast data access. Okay, so let's do this to GPU neural network. Okay, need to close some of this down and go here and go GPU. If I can type neural net pi, and we'll have a new chat. Why not? Add should be in chat mode, I think, but anyway, add no agent mode actually is what I need. This, yeah, here we go. So that will go on, and what does loop 1 do though? What does loop 1 do? So I will keep that, go here and go loop plus 1. So it keeps running, see? Okay. Mm-hmm. Okay. Okay. And finally, advanced GPU, multiple GPU programming. Data thing, different data, different parts of different GPU. Toggle M. Learn that. Toggle M. Dash M. Come on. I don't know what that was. is pretty cool. That is pretty cool. And with that, I think I will call it a stream. Just going through a game, learning a little bit about GPUs. That was super cool. So, bye.